This is Inspiring Design, where unique innovators come together to share their knowledge, share their insight, and keep us up to date with the latest industry trends. And here's your host, Roshan Senanayak.
What's up, listeners? Today's episode is an exciting one where we're literally going to speak about rocket science. So joining me today is Carl Damian, a lead propulsion engineer at Gilmour Space Technologies, developing rocket engines as a part of a small satellite launch vehicle. After graduating from the University of Queensland with a bachelor, first class honours by the way, and the university medal, not to mention his Masters of Mechanical and Aerospace Engineering, Carl was named as the only Australian in the 2017 US Aviation Week as Tomorrow's Engineering Leaders in the 20s, an international award recognizing the future leaders of the aerospace industry. His previous role was a mechanical systems engineer at Boeing Defence Australia, working on the interoperability upgrades for the 737 Wedgetail airborne early warning and control aircraft. So without further ado, let's get straight into it and learn about the aerospace and aviation industry. Carl, welcome to Inspiring Design. Can we start off with a little bit of background of yourself? What's your story?
Yeah, hey Roshan, great to be here and I guess talking about my favourite subject, space.
Yeah, absolutely.
What I do. So, my name's Carl, I'm an engineer at Gilmour Space Technologies and I'd like to share a bit about my story and then also a bit about the aerospace industry and why you can actually be a part of it.
Perfect.
Something happening in Australia.
Yep.
So, I grew up in Townsville and then finished my schooling in Brisbane and I guess I was lucky in that I had an idea of where I wanted to go, what I wanted to do. I know a lot of kids, 14, 15, they're told you have to figure out your whole life's purpose when you're 15 in 1 or 2 counselling
And
years.
that's a horrifying thing when you're at that age.
Yeah, and I mean, I guess I was lucky enough that I kind of knew I liked planes, space, maths, so the engineering path was a good direction for me, but I can totally understand that a lot of students aren't. They have no clue.
Yep.
And hopefully during today, I might be able to give a few ideas for people
Absolutely.
to see if this is what they're interested in.
Absolutely. Now, you literally study rocket science. Like, that's what you do. So how did you get into it?
Yeah, so I went to the University of Queensland, did a Bachelor and Masters of Mechanical and Aerospace Engineering. And throughout the time at university, I was lucky enough, I guess lucky, but also proactive enough to go find a bunch of different experiences that kind of led me to where I am today. So I talked to professors, I tried to do some research and summer for free, unpaid work, just to try to get some knowledge. And a few of those things came to fruition. So one of the professors I knew, I was doing my master thesis, and he offered me a chance to go work for the German Aerospace Center, so DLR,
Wow.
German NASA pretty much, for my thesis.
Wow.
And that set me up really well. I learned a lot of things, I had gained a lot of experience, a fantastic thing in my resume, but that came about because I'd talked to him, I'd worked for him, I'd done free work in my spare time. And then through that, and also being involved with a lot of the clubs and societies, there's one Australian Youth Aerospace Association that operates both in schools and unis, and we can talk about in a moment.
Yep.
But being involved with that put my name out there, and I got to talk to companies like Boeing, companies like Lockheed Martin, all the big aerospace companies in Australia. And through that, I was able to get my first job as an engineer at Boeing. So I was on Boeing Defence, working on the Wedgetail aircraft, probably a little bit less known than the cool fighter jets.
Yeah, absolutely.
But essentially, they took a Boeing 737, like we fly into Sydney or Melbourne, and turned it into a flying air traffic control tower.
Wow.
So they put a big radar dish on top and took out all the seats and all these operator consoles so that, for example, in the Middle East, if they're trying to look after and manage all the fighter jets doing mission sorties. Mm-hmm. They can control them, but they can also say, okay, you're out of fuel, here's a tanker coming. Mm. If you fly to this spot, you'll be able to refuel. And they look after everything. It's kind of they call it battle space management platform.
Wow.
So that's really cool. We're doing an upgrade, got to do some flying in the jet and sit in the cockpit and take off and
So
landing.
do you actually, are you involved in the design and manufacturing side of the actual aircraft and the design of it?
Yes. So as Boeing, we were doing the upgrade. We're doing an upgrade.
Yep.
And I was in the testing team, so we got to go on the aircraft and push buttons and twiddle knobs and go flight testing and sit in the
cool.
cockpit for takeoff and landing. So
Yep.
very lucky to do that. But I got a few years in and realized that my real passion was in space. We had a big, an aerospace conference in Adelaide
Yep.
a few years ago called the IAC, and that's where the government announced that they're starting a space agency. And from that point, I knew I had to be involved.
Yeah.
So luckily, through a few other things, I knew Adam and James Gilmore, the CEO and founders of Gilmore Space Technologies, a rocket company down the Gold Coast. Managed to get a job, and that's where I've been for the past 4 years.
Love it. And I understand you're very close to actually reaching orbit.
Yes, it's very exciting. After many years of hard work, we have pretty much a rocket sitting on the factory floor down in the Gold Coast.
Yeah.
We're building a launch site up in Bowen, and the plan is to launch the rocket from there later this year.
Perfect. And so before we get into the actual industry as a whole, can you tell us a little bit about Gilmore Space?
Yeah, so we are a startup company based at the Gold Coast, and our mission is to launch satellites, build rockets. Our tagline is all orbits, all planets. So we're starting off by designing and building our first orbital rocket. That's the Eris vehicle we'll be launching later this year. But we're also building satellites to put on the rocket. And the whole point of a rocket is essentially it's just a bus.
Yeah,
or a transport vehicle to put your satellites or lunar rovers or space
But
probes.
surely it's 10,000 times
Yes.
more complicated.
Yes, it is. And I guess what we're trying to do at Gilmore and what's part of the new space industry is we don't want to build, the analogy is NASA back in the 60s and 70s, they built a Ferrari to go to orbit. They built the most perfect, well-engineered, expensive rocket to launch their astronauts, their payloads in. Cost a lot of money, but they had the money. Now we can't afford the same billions and billions of dollars to launch satellites into orbit. And because of the advent of mostly really smartphones and a lot of computing technology, satellites used to be the size of a bus. You can do stuff a lot smaller. You get satellites the size of a fridge.
Wow.
A washing machine,
Yep.
even satellites the size of a small cube that you carry in your hand.
Yeah.
And they can do more and more things. So
Yep.
as the satellites are getting smaller and cheaper, launch needs to get cheaper so that you can afford to launch these satellites.
Wow.
And that's been the big wave of new space companies. Elon Musk, probably heard
Of
about
course,
him in
of course.
SpaceX. So they first started trying to build rockets that were more like buses than Ferraris.
Yeah.
Cheap.
As a commercial flight almost.
Yeah. So essentially manufactured on an assembly line. A lot of them are looking at, Elon Musk has gotten to the point where he can do reusability, use them again. So we're trying to get away from this idea of having a very high-tech, complex, expensive Ferrari and turning it into a lower-tech, easier to manufacture, cheaper to make bus to launch satellites.
Yeah.
And that's part of what we're trying to do. We use different rocket technologies that we've developed here in Australia to make it cheaper, quicker, and easier to get to orbit.
That's pretty exciting, actually. So while we're recording this episode in 2023, where do you think we'll be in the next 5 years?
Yes. So for the space industry in particular, I would argue it's almost the second most exciting time to be alive. The first one was back in the 1960s, the golden age, first moon landing. But really, the past 5 years and the next decade, this is a great time to be alive and a great time to be getting into this industry. You've got seeing Elon Musk and SpaceX launching all these rockets is really driving down the cost, and all these startups coming along, launching rockets for the first time. Just last week and over the past few months, you've seen a few small companies launch rockets into space. Some of them have failed, but that's part of the game when you're first designing them. And we're hoping to be one of those companies that starts and grows. in the next 5 to 10 years, there's a lot of really exciting stuff coming along. So if we just look at it as the world or America as a whole, we're going back to the moon. We're putting astronauts around the moon in a couple of years under the NASA lunar project. We've got very large rockets launching. Humans are being launched from America back to the ISS. And some people may say, yeah, this is all overseas. What about Australia? But the good thing is all of that is then feeding into what we're doing in Australia in space.
Love it.
So we have had, in the past, we haven't done a whole lot in space, and people have thought, oh, it's too hard. We don't do that in Australia.
Yeah.
We do mining or agriculture. But Australia is actually really good at designing high-tech stuff. We've got a lot of intelligent people, a lot of fantastic universities and researchers providing all the knowledge and the skills. And Australians as themselves, we're pretty entrepreneurial. We're able to figure out problems, come up with ingenious solutions, not just have to follow the textbook each time.
Yeah.
So all that has kind of come together where we've got a fantastic, I guess, startup company ecosystem in Australia. There's more money coming along, more government funding, often driven by the Australian Space Agency, but also the federal government through their MMIC grants and other things. And we're starting to see a lot of fantastic startups in Australia growing. And in the next 5 to 10 years, you will see, well, Gilmour will be launching rockets. Fleet Technologies down south will have a constellation of satellites. We'll have put lunar rovers onto the moon. There's a space agency program to do that. And we will also have our first Australian female astronaut in space, Catherine Bonnell-Pegg. She's currently training with ESA to launch as a part of their program. So it's growing. And the idea is, hopefully, with the right direction, government support, and funding, all the startups today in Australia will become the Australian prime companies. They'll become our equivalents of Boeing and Lockheed
SpaceX and
that.
so forth.
Yeah,
and I think
SpaceX.
I think I recently read a report where the space industry is seen as the 16th biggest industry at the moment. This was, I think, 2021 or 2022. But I feel like over the next decade, as you said, with all these movements happening, it may go to the top 5. I feel like when all of a sudden one breakthrough can catapult it into the top 5. I feel like so exciting time to be alive. So it's almost sounds a little bit out of reach for general people, but you've obviously been able to take the Australian education that you've received with your own tenacity, with your own skill sets and whatnot, and then achieve something very cool. So I want to break that down into the granular pieces almost, so that the listeners, whether they're teachers or students or anyone else really interested in it, can understand almost the steps to get there. So the first thing that I want to understand, and a common question, although seems a bit obvious sometimes, is why is the aerospace always bundled together? It almost seems like space is a whole different thing and aero is within the orbit or within the atmosphere. Where's the actual line? How do you define it?
Yeah, so I guess if you talk about aerospace as a whole, it's everything from the ground up to, I guess, as far as you want to go. We've got Voyager 2 probes well beyond Pluto.
Yeah, I see.
But really the defining line is the von Karman line, which is 100 kilometers above the Earth's surface.
I see.
That's the most commonly accepted definition of below 100 kilometers and above 100 kilometers is space.
Okay.
So CASA, our Civil Aviation Authority, they look after everything below 100 kilometers. So you could call that the aviation or aeronautic area. So that's where you get planes and helicopters, drones, balloons, and that sort of technology. And then once you go above that 100 kilometers, that's where you get into space. And that's the domain of the Australian Space Agency. So that's really rockets, satellites, unmanned probes, that sort of area.
Exciting. And obviously you're working within that sector outside of the actual 100-kilometer line.
Yeah. It's kind of, the line's kind of you've got an atmosphere or you don't really have an atmosphere to deal with.
And so did you have a liking towards space when you were growing up, or were you directed by an educator, or how did you come about? How did you manage that interest in the high school level or even primary school?
So I remember when I was a kid, we used to make paper planes with Dad. We
Of
used to have
course.
this paper
Yep,
plane
yep.
book, and you come up with all these crazy designs, and you throw them off the balcony, and you realize that's actually quite hard to
Yeah.
build a really good paper plane.
True.
I think recently there was a team of Boeing engineers that managed to throw a paper plane like 100 meters or
Oh, wow.
something crazy like that. So that kind of started, and then more books about planes, both from back in wartime and reading. I don't know if anyone's read the Biggles books. He was a explorer slash fighter pilot back in the time, and that kind of got an interest in aeronautics, and space was there. Obviously watched Star Wars, and that was cool, but for me at that time I was mostly interested in planes,
Right.
and that's kind of the direction I went to
Yep.
university, managed to follow my dream to Boeing. But as I got a bit older, I just realized how, I guess, inspiring and cool, or even hard to interpret the concept of how big space is and the difficulties trying to go to other planets, exploring new worlds.
Yep.
And that kind of started to bubble up within me, and I got to go to a couple of space conferences, get involved with my master thesis, and that tipped me over from, rather than planes, I'd rather go work in the space side.
I see.
And I think one of the main things I'd like to help people understand throughout this podcast is that you don't have to just be a boffin or an engineer, rocket scientist to work in this field.
Yep.
We need people with all sorts of skill sets. You need engineers from all engineering backgrounds, but you need tradespeople, technicians to actually go build the rockets, maintain the aircraft.
Yep.
All the hands-on skills people like to build things. We need software engineers and IT engineers to take the data from satellites and make something useful for it.
Yep.
So, for example, use an app that takes photos of a farmer's field, and it can tell them which crops you need to water, which parts are under higher drought. Use AI to track marine mammals, essentially take images and identify whales and track their path as they migrate along the eastern coast.
Yep. Yep.
We need people to run a business. So every company needs people who got business degrees. We need people to buy rocket parts for us, right? We need people to do marketing communications, tell the story of why space is important. So that's all the people with the creative side. We need people with accounting backgrounds to help pay our bills.
Of course.
Right? So you need everything that a business normally needs. And on top of it, obviously, you need
The specialized people.
The specialized people, the technicians and the engineers.
Yeah, yeah. And if you're interested in these things and you're not following a conventional pathway, what are some of the subjects they should be studying at a school level almost before they choose? Like even yourself, you were first interested in the aero context, planes, but then went on to a space context a little bit later on. If they're not sure, but they're interested in these kind of things, how can they set up a foundation so that they've got pathways that they can choose from? What should they be studying in school?
Yeah, it's a really good point. And I guess I'll answer it in two parts. So firstly, if we want to focus on the engineering side. So it's all about having a basic understanding of how the world works. So you'll be doing your Maths B. Maths C is optional.
Okay. Everyone would think rocket science, you need a Maths C.
So Maths C you can do at university as a bridging course.
I see.
If you don't do it at school. And that's fine. One of the sciences, physics and chemistry are probably more tailored to this than biology, but if you do biology, it'll give you the basic scientific understanding. And again, you can do bridging courses at university. If you don't get the required marks at university, that's okay. There's a lot of pathways to go do diplomas at TAFE, get into a different subject at university like science or something separate, and then transfer your credits over. So there's lots of different options. Don't be too worried if you don't do the exact Math B, C, physics, chemistry, Suicide 6, I think. They still call it. And go.
I was very close to that myself, actually, but simply because my teacher had a very similar understanding and approach to guiding me, and I was, I think, pointed towards physics, chemistry, Maths B, Maths C, and then tech studies and graphics.
Yep.
Back then, they were the design subjects pointing towards architecture, right? So, and he came from a similar mentality of telling me that you need to understand how the world works, how the material understanding is going to help you design better, and therefore your structures are going to get better. Therefore, if you at a molecule level can understand those things, it's naturally going to inform you better. So I think that bridge in connecting where these subjects can lead to the students is a very important thing for the educator. And so that's really good to know. And even if they're not fully aware of it, they can do bridging courses in the university context and still explore these things. So you mentioned they were the subjects, but let's talk about the actual skills. What are the key skill sets that might not be called an actual subject in a school or a course or anything like that, but what are the day-to-day soft skills that a person needs to work in this context?
So there's kind of two sides. You've got your problem-solving side and understanding how things work. So the problems we deal with, there isn't an answer in a textbook. I can't just go look up an Australian Standards Manual and it says do ABC.
Of course.
They're new. So getting comfortable with the idea of having a problem that may or may not have an answer or no one knows the answer, an unbounded problem, and then working through that problem to solve it is great. And part of that is one thing you can do is learn to take stuff apart. Figure out how it works, put it back together.
Yeah.
Because if you can understand how stuff works, you can understand how to design it.
Yeah.
And I think that's a skill that's very important for both engineers and obviously or people who want to go into the trades or vocational side. Take stuff apart, learn how it works, get a model plane kit, build it, fly it.
Yeah.
Even if working on your car with your parents, that's a good one too.
Yeah. Yeah.
Getting involved and learning how stuff works, and both at school and at university, getting involved with clubs, societies, just things that are outside your schooling that teach you how stuff works, but also how to interact with people.
Yeah.
'Cause that's what a lot of companies are looking for.
Yeah.
If I focus just on the university aspect,
You wouldn't be here.
yeah.
Exactly.
But if I just looking at university to start with, if you just do your degree, it's quite hard to get one of those coveted jobs. Companies are looking for people with, they call them soft skills, but pretty much in the end, it's can you talk to people and can people understand you?
Yeah.
So if you get along and get involved with organizing events or being a part of a club, where you go to networking events and talk to people, you'll slowly figure out, people aren't that scary, and you learn how to communicate with people, different people you need to communicate with in different ways.
And I think that's where from a educational perspective, words like emotional intelligence, resilience, and human intelligence and understanding learning styles, personalities, public speaking, or different types of those complementing skill sets that come with it. So I love that. And you mentioned problem solving. In my field, and honestly referencing every single one of my podcast episodes, design thinking is the word for it. Do you hear that term within your aerospace context?
I guess so, and might be called by different
names.
Vernacular terminology. But the idea is to say, okay, we have a problem to solve. How do we then go figure out what to do? And it's that kind of taking a step from the launch a satellite into orbit to actually having something. That's a really hard link.
Yep.
And it's coming up with, okay, well, what do we need to achieve launching a satellite into orbit? So there's various options: balloons, rockets, space planes, etc.
Yep.
And then taking that problem and just distilling it down further. Well, if you're going to have a rocket, what sort of rocket? How big? What sort of fuels, etc. And then once you've broken all that down, then you can go ahead and try and figure out how to build that.
Yep.
But it's going from I have a goal or a final aim to how am I going to do that? That's really hard.
Yeah. And that is literally the design thinking process, because you have the initial challenge or the insight, then you're spending time researching and understanding. You explored a whole variety of different options. You might do a prototype of it, low fidelity, and then eventually high fidelity testing continues. So you are describing it, it's just called something else. So there you go. Now, that's the problem-solving skill set. They're the complementing soft skills, subjects. Let's talk tech. What are the technologies that's front and center? You've already mentioned a few things already with, the complementing apps or softwares and engineering and whatnot. But what are the actual key technologies playing a big role in it?
So I guess if I describe a typical day that I would have, I'd come in and I'd log into Microsoft Office to check emails.
Yep.
And send emails, write reports, PowerPoints, Word. So having all those basic Microsoft Office skills.
Yep.
Essential.
And
for
I just
pretty
wanna,
much any industry.
Absolutely. And I just want to kind of take the opportunity to flag the time that we're in today where we're still writing emails. I feel like with what the Office suite is doing with these AI integrations and the new language modules, we might not have to do that in the near future, I feel.
Yeah. Yeah, it'd be interesting to see once they integrate ChatGPT what
Exactly.
they'll be able to do with that.
Exactly. So Microsoft Copilot just released 10 days ago and hasn't hit our shorelines yet, but I'm very interested to see what that does because I feel like every person who uses any form of Office Suite on a day-to-day basis will have to change their workflow. But we're going off on a tangent.
Yeah.
Back to you.
And then say, for example, I might spend the morning designing a new test stand. I spend a lot of time with the rocket testing team. So I'd be on the computer using computer-aided design, so CAD software to draw.
And what are the softwares you use?
So we use, in the industry, there's quite a few, but your biggest ones would be SolidWorks, CATIA. It's often used for aerospace a lot. And there's a lot of new softwares coming along which are cloud-based.
Okay.
So another one called Onshape, which is cloud-based CAD.
Yeah.
But they're all pretty much the same. If you can use one, you can learn the other.
Absolutely.
So I might spend time using that software to design a test stand. Then I might put it into some of the analysis softwares to then figure out, is it strong enough? Is it light enough? Etc. And then in the afternoon, I might be out testing. So I might be on console, pushing all the buttons, controlling the test stand, hitting the big red button, making fire. And then afterwards, we have to analyze the data. So we write a lot of computer code, software code to transfer all that data into something useful and meaningful. So basic coding skills. Doesn't really matter, again, which language, C++, Python, etc. Having basic coding skills to be able to figure out, okay, I got to do this problem. How can I make it easier rather than doing it all by hand? So, and then if you're looking at sort of kind of the technician side, a lot of things are going away from you have a procedure to make a part. That's all based upon just paper. You're writing stuff down. There's a lot of apps you're using where all the procedures to make parts and all the designs are on the app. So you have to be familiar with using those apps, how to interpret drawings, and then feedback that knowledge to engineers. So if you're just building something, well, not just building something, but if you're the tradesman, you need to understand a bit of the design and process as well. Because if you have problems, you need to be able to tell the engineers what it is, and so you guys can work it out together.
Makes sense. Do you find yourself doing any form of sketching like we literally do in high school in your day-to-day?
Yeah. Often it's a lot quicker to just get out a pen and paper and draw something to get the idea across and come up with concept ideas. And then from there you can take it and flesh it out further in the CAD software.
Yeah, makes sense. And do you find any integrations of VR, AR coming into play within the aerospace sector?
So this is a very interesting one. And I know that Boeing was doing a lot of work with this. One really cool thing they were doing was using virtual reality to help technicians maintain aircraft. So they put on the VR goggles rather than having to flick through a stack of
Training
50 or 100
Yeah.
pages. They can go out to the aircraft and they look at the aircraft and it'll highlight the different bits they need to change. So it'll be like, remove this part from the engine. It'll highlight it and tell you all the tools you need and all the parts you need. And they'll go do that. And then the next step is, okay, here's the other bit you have to remove. And then you go through that process. So rather than trying to figure it out from a bunch of paper, it's speeding up the process because it's telling me directly what they need to do.
Yeah, awesome. There you go. And I feel like we can talk about this forever, but I'm mindful of time.
Yeah.
I'm mindful of time. But if students are interested, and I know just from talking to, regular high schools, private schools, to independent schools, doesn't matter where I've traveled, there's always students interested in rocket science and going out of this world and reaching the moon and, a whole bunch of these things. If they're interested in this sector, what's your advice for them?
Yeah, so my two takeaways, or what I'd like to impress on people, is one, there is an industry in Australia, and there's a lot of jobs out there if you go looking for them, right? And over the next 5 years, it's only going to grow.
Yep.
So there's jobs out there, and the second point is you don't have to be the top of the class boffin or brainiac to go work in there.
There you go.
Need people with all experience, people from engineering, civil, all your technician roles, all the way through the business, etc.
Yeah.
So there are jobs, and all your different areas can work in that area and contribute.
Absolutely. And even as trades pathway, as simple as steel tradesmen or
100%.
plastic molding, injection molding, all of that needs to work within that context. So I think that's the message that sometimes gets missed in thinking that rocket science is, something well beyond this world.
Yeah.
Sometimes literally in people's minds, but it is actually on our doorstep.
Yeah, we need electricians, we need welders, we need boiler makers.
There you go.
We need people who can cut metal and solder connectors.
Yeah.
And to get there, obviously, it is still competitive. So having the right skills is mostly about getting out there, getting involved. So different ways to do that. And I think at a high school level, there's the Aerospace Gateway Schools program. I know a bunch of schools that are a part of that. That's a great one. But if your school isn't a part of that, that's fine. There's a bunch of other activities and groups going on. I briefly mentioned the Australian Youth Aerospace Association earlier. It's a student-run network, mostly at university, for promoting the aerospace area. But each year they do a high school camp, generally at University of Queensland in Brisbane, where 100 to 150 high school students come together with a passion for or
Space
interest.
camp.
Yeah, it's a space camp.
Love it.
And we go to the military base and get to climb around in the big jets. We sometimes go out to the airport and get to see the Qantas planes.
Love it.
We build and launch our own little rockets, learn about what the jobs are. So that is a fantastic camp for people to get involved in. There are scholarships available for students who don't have the financial means to get there themselves. And I'd highly recommend any teachers to find out about it and recommend it to any students who are interested.
And that was actually my next question.
Yeah.
What's your advice for your teachers?
Yeah, so I guess it'd be getting at and try and find these different camps, opportunities, university events that students can get involved in. And then kind of impressing upon the students that you don't have to be a rocket scientist, right? If you've got a passion and you're interested, you'll be able to get there.
Absolutely. And I think you can, the thing you mentioned before of just making paper aeroplanes and making a competition out of it, see if you can continuously refine and get there, I don't know, a longer distance. I feel like I want to go do that. So I love that. So how can they get in touch with you if they want to learn more? Maybe about Gilmour Space, maybe about asking about the industry. What's the best way for people to get in contact? Yeah,
so if you go to our website, gspace.com, we've got a section there. We've got an email. You can ask questions. We often do school visits. So we'll send people out to talk about who we are and what rocket science is, kind of like this. We occasionally have schools visit us, and we occasionally also do 1 week internships. So if teachers are interested, I encourage them to reach out via the website. And we've also got a page on there that lists all our different STEM engagement activities that we've done, so you can go and get an idea of what we do.
Perfect.
On that. And then if there's a way for you, I'll give you some links to, say, the Australian Youth Aerospace Forum, a couple of other groups that you can display with the show notes for teachers to go find out other things. I'm sure there's a lot of other stuff out there, but these are the ones that I've been involved in. Perfect,
mate. And absolutely, yes, jump onto the show notes and check out those links. We'll make sure to include them. Now, at the end of every episode, I do more the recent episodes, actually, I should say. I ask a random question, and I want to keep it in the theme of space for this one, but and I have a feeling of what your answer might be. Okay. But what's your most favorite space-related movie?
Ooh, so Star Wars is nostalgic,
Okay.
but
Because you grew up with it?
Yeah,
Cool.
because you grow, and it's a bit of fun.
Yeah.
and everything. If I'd be tossing up between Interstellar or The Martian,
Interesting, yeah.
but I think I would have to go with The Martian just because of how fun it was.
Yeah.
Matt Damon was out there growing potatoes in
Yeah.
dirt and coming up with all these weird and wacky ways
Yeah.
to survive on Mars. And by 2030,
Yeah.
Elon Musk may be on Mars.
Absolutely. I feel
So
like
we're gonna have to-
he's suitable to be the first Martian, actually.
Yeah, yeah. He's an interesting one, but yeah, from an engineering point, sitting there and watching the movie and reading the book as an engineer, I'm like, this is all pretty plausible.
Yeah, and I think a lot of the things you mentioned, you can see in the movie as well. Like, he was constantly problem solving, but he had a base understandings of the sciences and, the resiliency in his mindset and making sure he understands how to look after himself. So yeah, I can understand. There was a recent one that I saw called Life that absolutely was if you haven't watched it, definitely recommend it.
Yeah.
There's a stellar cast in it. There's Ryan Reynolds, I think Jake Gyllenhaal. So the stars is what attracted me, but then it ended up being a very left-sided type of movie. But no, look, thank you so much, mate. It's been absolutely a knowledge fest, I'm going to say, because so much information. Absolutely. And hopefully people do reach out to you. And thank you so much for your time.
Fantastic. Hope everyone's learned something.
That's it for today's episode. Now it's time to take action and build on the learnings to get inspired. First up, jump onto rashansenanayaka.com/podcast and check out the show notes, links, and other relevant learning materials from this amazing episode. Next, if you learned something new today, click that subscribe button and set yourself up to receive live notifications on future episodes, as well as more opportunities to learn from our amazing guests, brands, and speakers. Last but not least, it's time to have your say. Join the conversation and share your thoughts and feedback on today's episode with a review, all while joining many others with a 5-star rating for Inspiring Design with Rashan Senanayaka. Till next time.